Welcome back, everybody. We got one more statement to go over, one more conditional statement. This was actually called biconditional. It was at the bottom of a worksheet we did yesterday, and we ended up crossing it off. Biconditional. Symbolically, we already get this setup, okay? We know what all of this means, okay? Now, I know this looks crazy, but it's really not all that complicated. This says that P implies Q. In other words, the P has to come first. And then what does this symbol mean? That's our AND symbol. Okay, it's been a little bit of time since we really thought about the AND. So we have the P implies Q and the Q implies P. So basically we got the forwards and backwards. Okay, that's why it's called biconditional, right? Like a bicycle. Like anything that starts with bi is two ways or two things. So the easiest way to write it is with this arrow, okay? The double-sided, even if you want to use geometry, it kind of looks like a line, like a true two-directional line instead of a ray. This means that P implies Q and Q implies P. Now the definition is kind of crazy, okay? The definition is the conjunction, all right? And that literally just means the AND symbol, right? Conjunction is just talking about the AND symbol of the, so we've got the AND symbol of the P implies Q. Now, P implies Q, we didn't talk about this very much yesterday because we were trying to learn inverse, converse, contrapositive. P implies Q is the normal, boring version, okay? And that is simply called the conditional, okay? It was on the notes yesterday, but we almost like didn't even consider it to be one of the setups because it's just the normal one, right? And it's the backwards version, and the backwards version is called the converse because we've switched them where Q comes first. So I know that sounds crazy, but again, conjunction just means the word and, conditional just means that P implies Q, and converse just means that Q implies P. So it literally just means the P implies the Q and the Q implies the P.
You know it's hard.
What did you say? Well, it might be a lot of words, but again, I don't know that it's going to be necessarily super hard, okay? You read this as P, and it's weird because you're not going to say P both directions Q or anything weird like that. To say P implies Q and Q implies P takes forever. So we get P if and only if Q. This is something that really is super popular in like college math, the if and only if thing. But yeah, it basically means the two-directional arrow, if and only if. So again, once we do a question, you're going to say, okay, this is just as easy as all the other ones have been. I know we got a lot of vocab going on here. The truth value biconditional statements are true. Remember this statement and remember how picky the and is. In order to be true with an and conjunction, you got to be true, true. You have to be both true. And so this isn't all that complicated here. Both have to be true. We already knew that. That's not new information. If P implies Q and Q implies P, that and means that both have to be true. Now, what goes in these blanks? Again, conditional and converse, because that's talking about the first and the second. So, conditional and converse. The easy way to think about this, all right? It better be true forwards and it better be true backwards. If it's true forwards and backwards, That's it. You're good to go.
Sorry.
No problem. Thank you very much. Gotta get those grades in, right? Everybody bring them to me. Excellent. So let's see it happen. All right. Again, an easy way to think about it. It better be true forwards, and it better be true backwards. All right. It says, two angles are supplementary if and only if the sum of their measures is 180. This if and only if part literally is just the two-sided arrow. That means you better go both directions. Okay? So, the conditional is the forwards arrow. Okay? The conditional is the P implies the Q. Just the nice and normal direction. Okay? That is, two angles are supplementary and because we're talking about these in terms of conditional statements, we did this yesterday, we're going to use if-then statements. So let's slap an if in front of that. If the two angles are supplementary, then the sum of their measures is 180. You'll be all right. You'll be all right. You just got a little bit of gym brain. You'll be good. Trust me. Stay with me. You got this. So, we put the first and then the second. In order for biconditional, we also are going to consider the backwards version, right? Where instead of P going to Q, we could think of it like the arrow's also going backwards. Now, typically we don't write things like this. We don't like arrows pointing left in geometry. So that's why normally we would write it with the Q first. You know, we don't really like to write it like this. We much rather like it with the Q coming first. But either way, it's not that tough. We're just going to put the second sentence first now, okay? We're now going to put the second part of it first. Okay. The sum of two angles is 180. Then we put the first part. They are supplementary. I know we're doing some writing. I know some of us are starting to we're getting just enough vocab words that it's starting to just add up on us. But is the last vocab word as far as conditional statements go, is the last one. All we need to make sure is that it's true when you read it forward and it's true conversely when you switch the order. Is it true that if two angles are supplementary, then the sum of their measures is 180? Yeah. That is true. Okay, that was easy. Is it true that if the sum of two angles is 180, then they are considered supplementary? It sounds like the same thing because it's literally just the same sentence but backwards. It's not always going to be true, but for this question, both directions, it is true. And so, because both directions are true, then biconditionally, okay, remember what we're really trying to figure out is biconditionally, it's the new vocab word, this is true. And it's true because check, check. We got to have both. All right, we got 3 more examples. They have less to write. You know, hopefully we're going to get our groove here. We're going to see, okay, this really isn't all that bad. All right? So we just need to make sure. Going forward, it makes sense. Going backwards, it makes sense. Then we're good. So it says, I wear my snow boots if and only if it snows. Okay? So, forwards. If I wear my snow boots, then it snows. Then we just flip the order, right? Conversely, put the second part first. If it snows, then I wear my boots. All right. Thinking about these two conditional statements. The original conditional, just the normal straightforward one. If I wear my snow boots, then it snows. Is that true? Mm-hmm. All the time. The guy can put, or the girl, can put their boots on in the middle of July, and that's going to cause it to snow. This is a false statement. Okay? Yes, you're mostly wearing your snow boots when it's snowing, but wearing the snow boots is not causing the snow. Conversely, if it snows, then I wear my snow boots. That does make sense, right? It's already snowing, so they toss the boots on, right? Excellent. Now, to finish this off, biconditionally, both directionally, is this true? This is biconditionally false. Biconditionally. It is false. It does make sense that if it snows, I wear my boots, but it doesn't make sense that if I wear my boots, then it snows. Okay, let's do one more. Do you want to do the mathy one or the 10% off one? 3 or 4? Okay, I heard a couple people say 3, we'll do 3. Sorry if you said 4, I just didn't quite hear you loud enough, and I'm sorry. Number 3, okay? X squared equals 25 if and only if x equals 5. Okay? We got to make sure that it makes sense forwards and backwards. Okay? So, we're going to need if-then statements. Conditional just means the typical forward part here. If x squared equals 25, then x equals 5. Conversely, anybody got the converse set up? What do you got?
If x equals 5, then x squared equals 25.
Absolutely. And I hope you're not stressing that. I hope you're not nervous. It's the forwards and the backwards. And they both have to be guaranteed true. All right. Does anybody know trues or falses for either the conditional or the converse? So somebody say, raise their hand, and then say, I think that the conditional is blank, or I think that the converse is blank. What do we got? Kevin, what do you got?
I think it's true.
You got to tell me. Conditional, converse. Which one are you talking about?
Conditional is correct.
Conditional, Kevin thinks is true. Okay? Here's what I'm thinking. What do we know about squares? Squares is timesing it by itself, right? So if you have like 3 squared, it's 9. 4 squared, 16. 5 squared is 25. But what about negative numbers? Okay? What about negative numbers? Because what is negative 3 squared. Negative 3 times negative 3 here. I'm doing a little bit too much mental math, I guess. My bad. Okay, so if 3 squared equals 9, what about negative 3 squared? What's negative 3 times negative 3? Two negatives makes a positive. So what we're getting is that actually, if we know that x squared equals 9, we've got two options. We've got a 3 or a negative 3. And so this is going to be a false statement. Because if x squared equals negative 25, maybe x is negative 5. I cannot guarantee this. There are possibilities where this is wrong. And if you can give me one counterclaim, right? This is false because of negative 5. Okay? You gave me one example, that's good enough. Conversely, if x equals 5, then x squared equals 25. What do we think about this one? I think this one's easier. This one's true. This one's true. If you tell me what x is 5. Okay. If x is 5, x squared is 25. 5 times 5 is 25. So biconditionally, what do you think? We have false, true. In order for biconditionally to work, you need true, true. And we do not have true, true. We have false, true. This is a false statement. All right, I think that's good enough for biconditionally. We're going to do a couple more kind of review things, but this is our last conditional setup. Okay, we've talked about inverse, converse, contrapositive. Really, biconditional is just the boring version and the converse. You got to have them both true. Easy peasy.